Okay, so let's move on. So for this next example, I'm going to actually take a deep learning model, and I'm going to show you how to take a model from the Tensorflow object detection API and wrap it as a capsule. So we want to take an existing model, and we just want to very easily convert it into brainframe format. And so Tensorflow object detection API is a great library for training your own detectors. And so it's very mature. It has quite a bit of different models that are supported by it, and they're always adding new features. So we have special support for TensorFlow object detection models to make it very easy to turn them into capsules. And you can see their model Zoo has a variety of different pre-trained models with different speeds, bounding box outputs, precisions for different, all kinds of different data sets. And so for this example, I'm going to show you how to make a face detector. And I'm going to show you a little bit of behind the scenes on how we load the model, how models get passed to the backend, and how to use the TensorFlow object detection API. And after that, I'll show you how to do the same, but for an OpenVINO model. So great, let's get started here. And of course, feel free to put questions in the chat. I'd love to hear what you might be confused about. Okay, I see there's just a question. Yeah, the ID is PyCharm. I highly recommend it. Great, so we have our basic capsule. Let's close the book on that. And let's create a face detector. And so I'm going to go ahead and create a capsule. I'm going to call it face detector. Oops, okay, let's see. Hope this doesn't freeze again. Great. And of course, I have to have the meta.conf, so I'm just going to copy that over. All right. And I need to have a capsule.py. Great. And as always, we have to create a capsule class. So I'm going to go ahead and do that. Oops, okay. And we're going to name it face detector. Now, I highly recommend making the names unique. So kind of by definition, your capsule name should be a unique name. You cannot have two capsules with the same name. So just avoid having the same name for your capsules if you have a capsule library. So we're just going to add a description here. Great. And then we're going to specify the versions. This is version 1. And so for input type, I promise I'll show you how to do an input type, but that'll be for the next example. So we'll have a node description here, and to specify the size. So it's none again. We do not require an input. This is a detector. It does not classify. We don't need anything from another capsule. Output type equals node description. And so this is going to be, oh yeah, sounds good. I don't know why that resets for every file. I just forget about it. Thanks. So again, this is going to return all faces inside of the frame. So I'm just kind of telling brainframe what to expect. And we're going to give it face. But this time, I'm going to specify something else. So I'm going to tell brainframe that I'm going to give it some extra metadata. So this is anything under extra data is essentially just any data type that can be JSON encoded. And so this is sort of just a way to give Capsule developers the ability to get their data into the database, even if it's maybe not that easy to query for. And so we're going to output the detection confidence. And so this is just going to be a float value. from 0 to 1 of how confident the model was at detecting that face. Great. And then for options, we are going to have a threshold. So we want to be able to filter out bounding boxes which have a low detection confidence. So this is going to be a float option. And we can give it a description. So filter out bad detections. It's going to have a default value, 0.5. So that means anything that the model is 50% or more confident about will be sent to BrainFrame. We'll have a minimum value of 0 and a maximum value of 1. Great. And so we could specify some more options, but this is where I'll leave it at for now. And of course, please make sure to ask questions in the chat if you have any questions about what I've done so far. So last time, what I did is I imported the base backend. And so if I click on here and I go to the VCap source code, so this is under VCap repository. I'm just looking at source code. When I pip install VCap, right? These are the files that came with it. So this is the base backend class, and so you can see it's pretty simple. It has the process frame method, the batch predict method, and we have to implement that, and the close method. And so I could load this model myself, so I could make a backend that comes from base backend, or I can use some of our helper functions. So let me just go ahead and let PyCharm implement all my abstract methods. Nice. So these are the methods that I have to implement now. So again, we're not going to return anything for the detection node. For the frame, we're going to receive a NumPy array. And so this frame's shape, here, let's just, I'll just go ahead and describe to you what this is. So this is going to be a NumPy array of shape, frame height, frame width, 3. And so 3 stands for RGB, right? And so the detection node will be none because our capsule doesn't need anything. And the options is going to be a dictionary with threshold 0.5. And so this is because we specified here that we have an option called threshold, and the default is 0.5. But of course, the user can change this through the BrainFrame client interface. And so for the state, we're just going to ignore this. But that'll be ignore this. Unless you're making a tracker, which requires the ability to keep track of data between different frames, I recommend just don't worry about this. And so you might be wondering, well, okay, where do we actually load the backend, right? So we need to make our backend loader here. So this is where we pass capsule files device, right? And so we make a backend. So in this case, we actually care a lot about these capsule files. And so what I'm going to do is I'm going to copy over. I need to actually get a file. I need to get this face detector model. So here on our capsule zoo, the capsule I'm recreating is called Detector Face Fast, and we already have a detector. Oh, sorry, I'm like forgetting what I'm saying here. A already trained face detector, and so I'm going to copy that over here. And so to ship with the model, you just have to have it inside of the directory. So now BrainFrame will be passing that capsule files into the backend. But because we're using the Tensorflow object detection API, I can actually use some helper functions. That mean I don't have to do a whole lot of work to load the model. And so I'm going to show you how the model gets loaded anyways, but I'm going to show you through the helper functions. So this is where I can cheat a little bit. So I can say from vcap utils import Tensorflow, and you can see here we already have a helper for classifiers, but in this case we want an object detector. And so I'm just going to replace my backend here with a Tensorflow object detector. And so you might be wondering, what does this do for me? And so what this does for me is it handles loading the model into memory, into TensorFlow, loading it onto the GPU. It also handles the batch prediction, and it handles closing the model. So let's take a closer look at what's going on here. Okay, so this is our TensorFlow object detector. This is open source under the OpenCV Foundation. And so what this requires as input is the model as a byte string. So this is the fully loaded model file. And so it's going to be a PB. So this is where we need to feed the detector PB. So let's go ahead and feed these things one by one. So we have our backend here, and you can see it's complaining because I haven't filled in all of the different parameters. So model bytes is going to be equal to capsule files and then the file name that I want to load. So this is the detector. So I'm just going to call it detector.pb. And you'll see here that it's actually still complaining. It's asking about metadata. And so this TensorFlow object detector has a certain format that it expects to be able to work with. And so metadata is a JSON that includes all of the different class names for the model. So let me show you what I mean. So let's say you have a, let's see here. For example, here's a detector that can output different people poses. So jumping, running, sitting. So you need to be able to go from the neural network's output, which is an index, back to a human readable format. And so for our face detector, this is very simple, right? We just have, we just need the face and the background class. And so this maps anything, whenever the network names something 1, that means it's a face. So what I'm going to do is I'm going to copy this over to our face detector. And so now we have a second file, dataset metadata, that describes how detector.pb outputs its results. And so I can go back here and I can say that the dataset metadata bytes is going to be specified by this file. And so if you train a model with the TensorFlow Object Detection API, you can use our existing wrappers for that and have a very quick way to load the model and do everything. So we passed this into the backend, but you might be wondering, well, what actually happens to the bytes? How does it get loaded onto the GPU? So we're just going to inspect the code here. So we get the model bytes, we get the metadata bytes, right? And we parse the TensorFlow model, and we get a TensorFlow session and a loaded graph. From that point, we get the input node of the graph, which is the image tensor. And then we get the different output nodes. So we're getting from the graph the detection boxes, the confidence scores, the confidence class. And then we run an image through the model just to make sure, this is a fake image of zeros, just an array, just to load the model into memory. So by the time this has finished running, the model has been loaded onto the GPU. And so that's where we specify, like the GPU specified is specified by device. And so this is going to be, device could be something like GPU, for example, GPU 0, or it could be GPU 1, right? And so BrainFrame will feed this for every device, and it might instantiate this backend for multiple GPUs. And our parse TF model bytes function here allows you to specify the device. And so then we've been talking a lot about batch predict. So this this backend implements the batch predict for us already. And so it takes all of the images and it flips them from BGR, so that's blue, green, red, to RGB, which is red, green, blue. And that's because the TensorFlow object detection API is trained on images that are formatted in RGB. And then we do a little bit of sorting to batch as optimally as possible. But mostly what we do here is we feed these multiple images into the session here. And we get back the boxes and the scores for the classes. And so we do a little bit of processing on that. And finally, we return to the process image the results. And so I know that I went really fast on this, but from the user perspective, what this means is we don't have to, this is already implemented for us. And the close function is also already implemented for us, because you can see here on the base TensorFlow backend that we close the session once it's done. So I don't need to specify close either. So what do I need to do? Well, I need to somehow get this frame into the batch prediction API, right? And so the way that works is I can call self.send_to_batch. And this could be any kind of data that your backend requires. In this case, it's going to be the frame. And what we get from here is a queue. And so this will not process anything immediately. It returns a queue. And inside of this queue, we can wait to get the results. So I could, if I wanted to, I could batch process something, send something to be batch processed, do more work, and then get my prediction. And so here's where I would get back the results from the GPU batch processing. But in this case, just to keep things a little bit cleaner, I don't need to do any other work. So I'm just going to send my results to be batched, and I'll get them back. And so what this means is if I have 100 streams, all of them will be sending their things into the same batch predict function. And so all of these images will get batch predicted, and so everything will run more efficiently. So we have our prediction, and so this prediction is going to be an object that has confidence, and it has a name. And so this name is defined by the dataset metadata. So it could be face or it could be background. And so in this case, we told BrainFrame that we're going to return face. So we're only going to care about predictions that are, oh, and this is a list, by the way, predictions. And so now what we want to do is we want to create a list. We want to return detection nodes. So we're going to iterate over the predictions and create these nodes. New detection. And so now I need to import the detection node object. Let's organize this. And just like we told BrainFrame, the name has to be it has to be a face, right? So it can't be background. So if prediction.name is not equal to face, we don't care. We will just continue. Go back to the start of the loop. And so here we're gonna give it prediction.name, and we're going to also specify the coordinates. And so prediction.rect. So a rect is essentially a format x1, y1, x2, y2. But we need to convert this to the following format. We need to convert it to x1, y1, x1, x2, y1. So we need to convert it to a list of of coordinates. And so BrainFrame's VCap library has a function called rect to coordinates. So we can just wrap this and be done with it. And then finally, we promised BrainFrame that we would provide it an extra data of type detection confidence. So far I've provided the name. Now I need to provide the confidence. So here in extra data, one sec, I need to put a comma there. So I need to provide something called detection confidence. So detection confidence. And then now I need to give it the prediction confidence. And now we want to add that to our list. And finally, at the end of process frame, we want to return this. We want to return all these new detection nodes. Awesome. And so I think our capsule is ready to be tested out. So at this point, just like last time, all we need to do is restart BrainFrame. So BrainFrame is not running right now, so I'm just going to go back here, demo. So we're just going to Docker compose up and run BrainFrame, and then we'll go over to the client and we'll see the face detector get loaded. So let's make sure no errors happened here. And it's quite possible that I made a mistake, since generally code does not work in the first try. Okay, perfect. This is great. Okay, so you'll notice here's our face detector, and here we have the description, example of how to wrap a TensorFlow object. We have the threshold, and you might notice a problem. That is a ton of faces. What is going on? Why are there so many faces? And so this is because I forgot to add a threshold here, right? And this is supposed to be a threshold to filter out any bad detections. So we're getting a ton of detections. So we need to go back here and add that logic that uses the plugin option for filtering. And so what we want to do here is, we filter out predictions that are not of type face. Well, next we should filter out predictions that are not high enough confidence. So if the prediction confidence is less than, and so here's where we're going to use our options dictionary. And so we named our option threshold. So if it's less than the threshold, we will skip it. We won't return it. So that way we only create new detections when they are confident enough, and when they are of type face. Awesome. And so now we want to reinitialize the core. And so that'll rebuild the capsule. And let's give that a moment to happen. So perfect. So now we can run the client again. And hopefully we'll see less faces. So of course, you always have to wait a moment for the capsule to load into GPU memory. Okay, great. So we have our face detector here. And you'll see a distinct lack of faces everywhere except for where you might actually expect faces. And of course, the video is just not very well encoded. And so as people approach, you'll see the faces approach, right? And so we can actually live play with thresholds. So we can set it to, that's wrong. We can set our threshold to 0 and get all of these faces back. Or we could set our threshold to 0.9 and maybe miss some of these faces. So you'll see we're missing some of the frames.